Oh yeah. Yeah. So first of all, I would like to thank by I would like to start by thanking Jack and Jihong for this wonderful opportunity because it's a new field relatively. And it's a great learning experience as well because we never work on this field until we get such opportunities. So currently, our project is primarily based on claims. So targeting. Uh, Let me show the data set we have collected. So we have taken the Medicare claims data. So this is the best data set I can get on the data.gov regarding claims. So this is the data we have inferred, and this is primarily a data of of the diseases and the prediction of diseases and kind of which has or let me show you the data set first so that you better understand the kind of data it is. Yeah, so it has all the columns like which year, so locations, so data source, so on the topic, like the type of diseases that may have come. So this is the data value, and this is rate per 100,000, and this is the percentage in which certain people have got this disease or something. So this is primarily based on the uh, Medicare claims data. So if you use the description, so it has all this outpatient claims, the master beneficiary summary claims, and so we don't require all these columns. So only few columns uh, will be useful to us, like the year, location, the topic, and the data value, and might be this race or ethnicity. So we only gone for 4 5 columns that is useful for prediction of this column data value. So this data set has around 33,000 records. And what we have done, so we have just taken this data value as a target column and based on the feature column. So other than this target column, so we tried to predict this target column using the remaining data feature columns. So such as year, I'll show you later on. So which columns we have taken. So I'll primarily go through the steps we have followed. So these are the steps we have followed for predicting this data column using the remaining feature columns over here. So first importing libraries, so data cleaning, data preparation, so visualization and encoding. So this is the important step because this step has taken a lot of time because we did not know like which columns to take to predict this column. So initially we were going with all the 23 columns over here, but we were not getting good results in whatever regression algorithm we have applied on. So, and this technique was very useful to predict which columns are like this one gives all the columns in the order of ranking, like what columns are important in predicting this target column. So this was very important thing, and splitting data into training and test sets and applying those regression models and evaluation metrics and prediction algorithm. Let me go into our code. So we've primarily used Google Colab for the simple VOC here. And it's primarily basically a simple machine learning model. So which we train to predict a certain column. Okay, so let me briefly go like walk you through the code that we have put in. This is primarily a Python code. But most importantly, the Python. So we have struggled with the libraries, the exact libraries to use to clean or prepare the data. So just going through, this is the like we import pandas, numpy, matply. So these two are for visualization. So we primarily use Seaborn for beautiful uh, plots we're using. Is scikit-learn. So these are all this label encoder. This label encoder is useful for converting these categorical columns into numeric columns because the machine learning models doesn't understand this categorical columns like these, a kind of alphabetical. So everything is converted into the numerical data. So this label encoder helps our data set to convert these categorical columns into numerical columns. And test train split, so it is the library that is used to split this 33,000 records into 80% and 20% training and test split. So 80% of the data will be converted for training and 20 to test on that trained model. This is the linear regression. So this is the regressions we apply. So this library is useful for that, and this R1 mean square error. So these are primarily evaluation metrics, like how well the model is performing. So these two are important parameters to predict if certain model is performing to its best. Okay, these are all warnings, that's fine. So first we load the data here, and so we just take the shape of the data. So it's around 30,000 rows here. So it's a data type. So it's all primarily just having a brief info of the data. So what are the data types we have in certain columns, and this gives us the basic information of the data, like how many, the nulls, not nulls. So until this step, so it's just overview, and we coming to the second step. Uh, so we try to clean up most of the data which have missing values in their rows, which have null values, and which columns or which rows. So we try to optimize the data as we can. So this is just checking how many null values columns or rows are present in the data. So we dropped out all the missing values, like the rows which have missing values are rows which contain most of the null values. And yeah, this is checking again. So after dropping, so this steps drops all the rows which have missing values. This is data, and yeah. So step 3 would be data preparation. So as I said, yeah. So here this is the target column, but in this target column, as you can see, a few columns are in rate per 100,000 and a few are in percentages. So what we did, so we have converted all these values into percentage, so that we'll be having in same unit. So that is the primary purpose of it. So what we have done, so whatever the values that are in rate per 100,000, so we have divided by 1,000, so that it comes for per 100, or yeah, so into the same, getting the values into equal units. So this step is primarily for that. So data preparation thing. And we check the uniqueness of the data we have taken, because the more the unique columns, the better would be the prediction, because the duplicate values would not be helpful for us for better prediction in the later models we apply. And this is just checking whatever columns we have in the like categorical or numerical columns. We just checking, so whatever the category, because later we'll be converting them into encoding using the label encoder. That step would be here. So but before that, so after the data preparation is done, and this is the final data we have. You see the date, it has been converted into a rate percentages for all the columns which are in rate per 100,000. And going down after checking uniqueness, so we're just taking it, and coming to visualization, we tried box plots and trends. Here let's see the trends. So we primarily have taken 5 trends over data value and topic. Yeah, so this is the important column we have. This data val, yeah, this is the target column. So whatever we do in this model, so we'll do with respect to this column, because so all the features we use, so we try to predict data value using these columns. So visualization, usually we keep this data value as a target column. So this plot is mostly for topics like uh, there is so much of information in this, but the plot. So these are all actually, it goes for in what ranges this disease can occur. So it's kind of, these are all outliers. So we can ignore these outliers. But in this box plot, we have certain concepts called quartiles, like uh, half quartile, three-fourth quartile. So I don't go in deep into those concepts, but this is basically for plotting these topics over a data value. So this shows like how much the data is getting uh, varied on particular topic. So this is same with respect to breakout. So as we see in the data set, so they have mentioned we can this can be plotted against this race or ethnicity. So this data we have, this is a breakout column. Where is the breakout column? Uh, Let me filter this. Oh yeah, you see here. So in breakout, we have certain parameters like age, 75 plus, female, male, Hispanic, non-Hispanic. So so this column would be helpful for us to plot with respect to data value. So which is why we have plotted uh, breakout column with respect to the data value here. So this is also similar to this box plot. So it also shows us the spread or variation of this particular ethnicity race with respect to the occurrence of the disease. So I can see the data value is mostly how many times or what percentage of occurrence of this disease with respect to the breakout category. So that is the primary purpose of this data. And coming to location, so we have tried plotting the similar plot using the location as well. We can take different columns, but so we could find only few columns over here, so which can be plotted against the data value, which can be useful to us. So this is regarding the locations in the data, like this has, oh, I think almost all the states. And coming to the trends, so this is another kind of trend that is a line plot basically. So it just predicts like, uh, as I said, the data value over the course of years. So how the diseases have been changing. So it just gives us the overall, the trend of the data value over the years for different topics, I can say. And similar to the above plot, so it gives trend of data value over all the years with respect to these breakout categories. So like you can see here, so how this age factor and is non-Hispanic. So you can see overall. So you overall or non-Hispanic Asian. So what kind of ethnicity or race? So uh, people have that occurrence of disease with respect to the years and the data value here. And we can draw, actually, in fact, we can draw so many conclusions using these plots and trends. Yeah, if required, we can have a kind of points or anything using the conclusions we draw from these plots. And step 5, To apply different regression models on this data, we use label encoders, as I said. So these label encoders helps us to convert all these categorical columns or the alphabetical columns into numerical columns. If you see the location, like different states have been converted into its numbers, its respective numbers, like one for Virginia, two for Maryland, three for so kind of thing. So after that, again, we just make sure that it doesn't have any null data or anything. So we just drop out few missing columns. And yeah, this one, this step should be below this. So after having this feature importance technique, so we dropped few unnecessary columns. So yeah, so coming into label, so coming into model building. So, so this step, what it does, so it takes this data value into X, it takes the data value into Y because it's a target column, and so it takes remaining columns. So except data value, it takes all the columns into X data. This is primarily just splitting into a target column and feature columns. And step 6, as I said, so this was actually we struggled more with this one because we initially did not knew that feature importance can be applied because we were doing a lot of trial and error methods. Like first we have taken all the columns and we have dropped few columns, and we have taken only columns that we knew that would be helpful. But later, after applying this feature importance technique, so this technique gives us top 10 features that would be helpful in predicting the data column here. So data value.
So, Rajesh, I just realized that this meeting goes to 12:45 and not 1 o'clock.
Oh, okay. Then so I'll
So, yeah,
sum
in
it up.
the,
Yeah.
in the interest of time, I think we need to give Santosh some time here as well.
Yeah, sure. I'll sum
Um,
it up, and I'll just share
yeah,
this presentation with
okay.
you all so that you'll have better understanding of this. And
Okay.
yeah, I'll go
And
straight
if
into
we
the.
yeah, if we have time at the end, I think we can do questions for all the teams, I guess, for a minute or two. But yeah, please continue.
Yeah, sure. So yeah, conclusion. So just we've applied 4 regression models here: linear regression, random forest, gradient boosting, and XG You can see here the results were pretty good using that feature importance technique, and you see the ideal score of R2 is actually 1, and the ideal score of MSE is close to 0 because R2 is it's the ideal behavior of the model with respect to the data. Uh, after after these models, so we get the best. We get to know the best regression model that might be applied for prediction algorithm. You see here we have taken gradient boosting algorithm to predict that test data over here. And yeah, these are all columns we have taken for, these are feature columns. So data value is the target column. And finally, using feature importance technique, so we have just separated out these columns that would be helpful for us. And using these inputs, we can just predict this data value over here. Yeah. So yeah, on a brief note, so this is the simple machine learning model that we have used on this data set to predict data value using other feature columns. Yeah. So if you have any questions, I'm happy to answer, or as Jack says, we have some time at the end.
Yeah, so
Yeah.
what we'll do is we'll probably go a little bit over for those that need to leave at the 45 mark. Please feel free to leave, but we'll go a little bit over just for the fairness of time here, and then we'll have kind of questions, a little bit of time at the end for questions for all the team.
Yeah, sure. Yeah.
Thanks,
Thanks.
Rajesh. This is, yeah,
Yeah.
as you can
Thanks.
see, a
Thanks,
lot of
Jack.
work was put into this.
Thanks, Jack.
Uh, so Santosh, do you want to go next?
Yeah, sure. Thanks, Jack. Thanks for the opportunity to let us work on this new thing. So